Welcome to Delta Wings Aviation Academy, where we prepare you for takeoff.
Hello, pilots. Welcome to Delta Wing Aviation Academy, where we prepare you for takeoff. Today we will discuss lift formula. Fasten your seatbelt as we prepare for takeoff and take a look at the overall details from the sky. There are several different ways to describe lift. This formula is a mathematical representation of the lift force. Don't switch off just yet. This is not as complicated as it seems. This is known as the lift formula. Firstly, let's define some wing and air characteristics. This is a cross-section of the wing. If you slice the wing exactly in half, you will get the mean camber line. The mean camber line is the precise center of the wing's thickness. So at any point along the mean camber line, the top slice matches the bottom slice. The point where the camber line meets the front end of the wing is called the leading edge. The point where the camber line meets the rear end of the wing is called the trailing edge. When you join the leading edge with the trailing edge by a straight line, you get the chord line. The direction of the air movement relative to the wing is called relative airflow. The angle between the chord line and relative airflow is called the angle of attack. The speed at which the aircraft flies through the air is called airspeed. The projected area of the wing is called the wing surface area. The mass of air molecules within specific volume is called the air density. For example, more molecules equals higher air density. So let's have a look at the lift formula and its elements. Lift is a force. CL stands for the coefficient of lift. This value is determined by engineers as part of the wing design process. It lets us know how much lift the wing can produce at any given angle of attack. Thus, the angle of attack is the key component of the coefficient of lift. Rho is the air density, V is the airspeed, S is the wing surface area. We can use this formula to work out the aircraft's lift force. We won't do this here. For you, the pilot, this formula presents a clear illustration of the relationship between the angle of attack and airspeed. These two elements of the formula you readily control. What the formula suggests is that for a constant value of lift, if the airspeed increases, the angle of attack must decrease, and vice versa. So in this example, both aircraft are producing the same amount of lift, and both are maintaining level flight. The aircraft on top has a higher angle of attack, thus slower airspeed than the aircraft below, which has a lower angle of attack but faster airspeed.